And this is what you should do once or twice if you can't get your cooler installed. Do not force it, or you will break this mounting tab like I did. Let's take a look. This broke off and I tried to glue it back, but it was so small it was very hard to glue. And so I tried to add a bit glue to the sides as well, but this simply does not allow much anything extra actually. So what I'm now going to do, just in case, is I'm going to build myself a new tab here where there's nothing, and those red marks, they mark the position where I want it. And I've already covered this with protective tape. This isn't the best tape for this, but this will have to do. I don't have anything better at the moment. What I'm going to do is I have a nail here, just covered with tape, the other end of it at least, and it's hard to keep this in focus. I'm going to hold it like this and then add something here. This protective tape, this is very bad. It's just not meant for this. I need to place another tape here as well, because but when I hold this like this, I'm going to add something here to build a new tab, and that something, this is to fix some plastics. I don't actually know anymore what this is. I don't have the package anymore, but this is something, 2-component stuff. You mix them together and try to be very fast, because it dries very fast, this one. But this is what I'm trying to use to make a new cooler mounting tab here, and that's why the protective tape. And it's very easy to do something that you can fix, but I'm going to need something better here. This is very bad tape, and tape, because I hope this doesn't get stuck on that protective tape. But of course this is plastic as well, this socket, so there's a risk it won't stay there quite good. So for that, I'm going to try this plastic activator here. This is from the super glue I used to glue back this middle tab. Maybe this activator helps, I don't know, but at least I've tried something. Now let me try to find some better tape. Alright, this isn't really protective tape, but since I don't have to remove this from this nail, this will have to do. Let's try to mix this and hope for the best. I think this is some plastic repairs, whatever. I don't need much. Well, this This doesn't look good. Maybe I don't use this one. Let's take a new piece. Let's see. Of course I won't be needing nowhere this much, but it's very hard to get anything less. This is very dry, so you need a lot of force to mix it. And it will be hard to place it. Actually, let's, before I forgot, use the activator. Alright, I think that's about it. Now, I'm holding this nail like this. I don't know how well it shows the camera, but I need to be sure I don't glue that cover. And I need very little of this. Not easy at all. I don't know, is it going to stay there at all? I'm going to push down a bit. Here, that's the best I can do, but yeah, I can move this nail at the moment. Well, I can only hope I can get it out from there later. We'll just have to let it dry and see what it turns out to be. While the new clip on the slotket dries, let's put this thing together. I retested these drive rails and these are also screwless. So it's too bad I don't have any more of these, but I just don't. These screw holes do align. Here, I don't know what was I thinking last time, but indeed, you can use screw as well. And this third, that could be used as a 3.5 inch drive or with 5.25 inch drive. I removed this covers and for some reason this does not use rails, probably because for the 3.5 inch drive, but you can screw your drive there, but you can't use those rails. And this upmost, well, that's where the rails are most useful, because you can only access the screws from the back. There aren't any hole there. And I could just use these rails on the topmost drive. You can get this easily. This was the broken drive that now has that silver front bezel, and this one should have this one. So I'm going to swap this now, and then let's take a look inside. If I remember correctly, it simply doesn't detect the drive at all. It was working until it wasn't. Never the right tools around. Let's be gentle with this one. I should use something plastic. No, this was the kind of, you need to eject before you can remove this. And now I'm using just one more time this bad power supply. there is of course that hole that you can eject, but they're just not always that nice. There it comes, and actually we might just eject the other one as well, like so. And now it should be easy. You can even see here easily that this silver one, it is indeed painted, factory painted. Now here you can see these indeed are the same color. This silver one is simply factory painted, and that's what the silver colored really are. They are simply factory painted. So I don't really feel bad to paint this one. And let's take a look inside. I don't actually think there will be anything obvious, but you never know about capacitors. This is perhaps a bit too new to have bad capacitors. Were these from 2005 and 2006? But of course, that is 20 years ago. Well, maybe there could be, I don't know how much heat there will be when burning the discs, so maybe there is some heat to kill capacitors, I don't know. But yeah, nothing obvious on this side. There's our SMD capacitors. I need to remove this PCB. We might actually take a look under here as well. There's absolutely nothing under there. Is this the type you simply lift up? Yes, it is. And let's open these. Oh, still one more to go. Like so. And here it is. But absolutely nothing wrong with this one. Doesn't look like any would be leaking even a little bit. There's no corrosion on the capacitor legs at all. And absolutely nothing suspicious, and I didn't believe there would be. No obvious reason why this wouldn't work, and I didn't believe there would be anything that you can actually just see. So it needs to be, we'll just have to perhaps take a look some another time. So I guess we are going to put the original color back there where it belongs to, and just use the silver one for now before it gets painted. So this one is what we're going to use now. January 2005. And this was, I think, a bit newer model. Yes, this is ND352A and this is 3540A. I don't know what's the difference, but... And now, where do I want it? Perhaps top is best, because if I'm going to use the Teratech panel, and if I connect something to it, I don't want any cables on top of this DVD-ROM drive, so I think this is best to keep on top. So I'm going to need the rails here. No, I think it was first the bottom. Now this way. Quite easy actually. Alright, let's install minimal components so I can install Windows and DOS and all benchmarking software and everything else, so we can start testing what remains here, what not, doesn't. These should be in correct locations because same motherboard was supposed to be here originally, and indeed looks like it indeed is correct, and no screws here either. Quite nice actually. It went there very easily, perhaps a bit too easy. I wouldn't mind at least one screw, but there doesn't seem to be any. Actually, maybe I should just check if I have standoffs nearby. These may not be right height. No, you need something taller. I don't think I have anything else nearby. So, no standoff at least for now. And this is the slotket that wasn't broke. It's still there drying. The plastic is hardening. So we'll take a look at that later. But for now, I think I'll keep this Nehemiah here. And this postcard won't be needed. This is what I did to the post analyzer card. Something so you could see the postcodes. And if I place this to the ISA, this should just go here, but I need to open that cable, of course. So yeah, and there's soft power switch, so I can easily turn on these ATX systems, but this won't be needed now. In fact, I can remove this compact flash adapter as well. No, I'm going to remove this one, and maybe I should just try to find standoff that is the correct height. I know I have something, but actually I think I would need quite tall standoff, because these are screwed here deeper than this surface where I measured the standoff, and it was already too short there. And I'm absolutely sure I don't have standoffs that tall. So yeah, I suppose this will have to do. Screwless design isn't always the best design. But no matter, let's continue. Now let's hope this doesn't fall. No, the other way. Out of here. I suppose, if it stays there. No, I have forgotten something. IO shield, I need to find something. That of course needs to go here first. I didn't find correct type of IO shield. So this is otherwise fine, except we have game board and those audio holes there, but I placed a bit of aluminum tape and piece of plastic on the other side, so at least there's no holes now. I know it doesn't look good, but this is what I have at the moment. It's better than nothing, at least. These IO shields. But again, one more thing why I don't like ATX. When you have everything else, this certainly is missing. And I didn't have those standoffs. The ones I showed before, they not only they went tall enough, but the thread was also wrong. You're supposed to use the small coarse thread instead of the fine thread. But no matter, the cards will hold it in place, I'm sure. Yeah, I should have mounted drives first. This is now jumped to master drive. Actually, let's remove the drive gates. So this you can install after motherboard, but those, especially the last bottommost 5¼ inch drives, those you can't install. These I wonder what are these for. Looks like somebody has bent them a bit. There's something screwed there. Maybe second hard drive can be mounted there, but upside down, I don't know. Let's take a look. So this is going to the front, yes. So this way. Yes, you can mount second hard drive there upside down. Does it matter? But why you don't have anything here? I think it's perhaps more likely that there would have been another drive gauge below this, but there certainly isn't now. I wonder if thermal paste between drive and the drive gauge would actually help cooling. I've never tried it, and I'm not going to try it today either. And now disk drive. I think I was going to use another drive first, but I think this is something I've cleaned, and this is period correct October 98. But if it doesn't work, then let's open this one. More often than not these days, this require new capacitors. Well, perhaps a bit older than this one, but I had several floppy drives, all tested, stored in a box. When I tested them later, some of them, more than one, perhaps even 3 drives, simply didn't work anymore. And that of course points to the capacitors, because what else could have gone bad? And indeed, I think I fixed a couple of those by replacing capacitors. And some of those drives are designed like so that if you remove the PCB, well, the head alignment goes wrong. So you need to align the heads after you open the drives, and that's not nice, but I think only minority is like that. I wonder what kills capacitors on these floppy drives, because, well, they are usually mounted like this with hard drive under them. Could it be because it's usually capacitors right here at the bottom of the drive, close to the motor? Could this heat from this hard drive shorten the lifespan of those floppy drive capacitors? Who knows? Maybe now I need to mount the Teratect panel, even though I can start with this one, but I still don't know. Should I try to fix this somehow or not? Oh, these are the upper holes. This doesn't have. There's these bottom holes, and you need the bottom holes to mount this here at the bottom. Last drive. But so it would have to go in the middle. I guess that can't be avoided then, but I don't place this at the moment. Let's just worry about that later. There should have been hole. I don't know why there isn't, and also this bottom. Well, you can access just that one. There certainly could have been holes. And I could even make them, but it wouldn't require much. I'm going to make those holes. Alright, another attempt. Here are the two new holes. And I sprayed some zinc spray on top of it. It's a bit different color, but not that much. I think it's quite good now. And here are the holes from this side. Now you can access those screws. Here's the power supply fan. It's now all outside the power supply, this connector, because I want 12 volts. There's power fan connector right there, so I'll use that one. And looks like I should have connected this before. Okay, you can quite already see that this 12 centimeter fan, it's not in optimal position. It should be a bit more down here, but that doesn't really matter. Where do I connect these so they won't be on the way? I need to easily remove the CPU as well. So yeah, it would have been better if those ATX power, these would have come from this side and preferably be down there, but that's not. I can't change that. Actually, I should have placed this under the power supply, it seems. Okay, again. I don't think I should tighten it anymore at the moment. These are a bit short, I think. Let's place this one so I can see. So I can at least see how this goes. Okay, I used cable ties to get these at least somewhat nicer. They are quite hidden here. And I'll just use 2 screws at the moment. We'll hold it for now. And I don't think I should concentrate on this cable just yet, because I don't know what graphics card goes here, and I need to test stuff and everything. So it might be better if I simply use something and then later find optimal cables and see how they should be routed. And so let's just get this to working so I can run benchmarks, and we'll finish the build later. Yeah, it would have been too much to ask if this could have. It would have been long enough to put it like this, but no. Not quite. Almost, but not quite. I wonder, do these standoffs even belong to this case, because these screwless ones. Because I think the graphics card, it should have go a couple of millimeters down. These are not very good ones, I think. They don't hold the cards as good as they should. Plus the card isn't even completely down, so maybe I'll just have to replace them. But at least we'll see if this works or not. And for some reason we're looking at hard disks now. And why would that be? Can you guess? Here's a hint. 40 gigabytes, 40 gigabytes, 80 gigabytes, 120 gigabytes. And something is different with this 3 here at the bottom. 160 gigabytes, another 160 gigabytes, and 200 gigabytes, the one we installed to the case. Well, these all show as an 8 gigabyte drive, while these show as the capacity they're supposed to be. So basically we have bug in that BIOS that it detects any LPR48 drive, that means over 128 gigabyte drive, as an 8 gigabyte drive. And that's not good, of course. And that's quite unexpected actually. I'm using the Unofficial BIOS. I'll put link. I don't remember what it was called, but anyway. And it is unexpected that it fails so, because none of these drives have any jumpers to limit the size to 128 gigabytes. We can limit it to 32. This one as well. This doesn't show any limiting, but who knows, maybe undocumented jumper does that. But that doesn't really matter. You're not supposed to need 128 gigabyte jumper, because they simply should report maximum LPA28 size, and that's the 128 gigabyte on BIOSes that do not support LPA48. But for some reason it doesn't do that. Actually, I don't even know what how they can be 8 gigabyte. It probably encounters some error that it can't handle and disables the new BIOS extensions completely. So you must use the old BIOS that can access up to 8 gigabytes. That's the only reason, I guess. But whatever the reason, I'm not going to use this LPI48 drives here. So, oh, and also this 200 gigabyte Seagate, it worked perfectly according to the Seagate diagnostic program. I made the full test. But this drive, it's not noisy or anything, but it has this periodic, I don't know, it's perhaps not ticking, but it keeps some noise that I don't like. It's not nowhere near as quiet as this Samsung. The Samsung drives, I really like them. They are fast and quiet and reliable as well. And this was the alternative drive I was supposed to use, but I can't use this because of the LPA28 problem. So that leaves some other drives. I'm not going to use these 40 gigabyte drives, although there's nothing wrong with them. So I'll use this 120 gigabyte drive. That's the only I think I have at that size at the moment, and this isn't bad at all. This is something I bought back in the day, new, and this is 5400 RPM drive. These would have been 7200 RPM, so these are all faster. But when I bought this, I intentionally bought 5400 RPM drive, because I bought this for original Xbox. I added mod chip, but I didn't really use that for gaming at all, but as a media player, and quite a lot actually, and it was really good in that purpose. But I wanted this lower drive because it was supposed to be media player, so this needed to be quiet, but I didn't know at the time that also these 7200 RPM Samsungs are really quiet as well. Of course this is a bit quieter, but not that much that it really even matters. But of course another reason is the heat. And the original Xbox isn't designed to cool down hard drives that get hot, because there wasn't originally. You had that 10 GB silent Seagate, very good drive, or some other alternative that was 8 GB, but whatever. So I wanted quiet and cool drive, and even if it means it would be a bit slower. But since this is something I bought originally back in the day, it's really nice to put this in the system. But perhaps faster drive would have made some impact on Windows performance, even though I now have so much RAM that maybe it doesn't even matter that much. And for those, it of course doesn't matter. And if you think what kind of drives used back in the day, well, they were 5400 RPM drives. So yeah, this speed is still faster than what was back in the day. So yeah, I think this is really good drive. I remember when I had a Asus P3B-F system, I originally used my 1.2 GB Seagate from the previous system, and then bought 10 GB IBM drive. It of course felt really big, but as usually with hard drives, no matter what size you get, well, they are always 90% full, so that wasn't no exception. So there's really no point to limit yourself to period correct drives. But the 10 GB would have been such period correct drive. But there's something else as well. Let me clean this one. So another power supply, and how do you supposed to pronounce this? Light on? I don't know, but it's Liteon for me. It's a good manufacturer. It makes quality power supplies, as I've read on the Vogons recently. And I believe that because this is considerably heavier than the Nexus or this cheap awful thing we measured in part 1. It's probably double the weight, and that's of course one way to know a good quality power supply. They don't make them heavy without a reason. But why is it here? Well, the fractal design fan, now that I connected to the motherboard and went into the BIOS, it reported it's 1000 RPM fan, and I completely believe that, and it pushes very little air. Let me open this. So I'm a bit afraid to use that fan, although I did run memtest. It took over 3 hours to completely test the 1 GB RAM, and it was completely fine with fast timings, and air it pushed didn't feel warm, so I don't think there was any risk of overheating or anything, but it pushes much less air than the original fan, so maybe I shouldn't take any risks. From my experience from other power supplies with 80mm fans, well, 1200 RPM is also too low. And I remember replacing one fan with first 1200 RPM Noctua, and it didn't push air as much as I would have liked. It was of course very silent. But then I replaced it with 1800 RPM Noctua, and that felt quite good actually, and it wasn't too noisy. So I think it's about the same, maybe 1500 with this larger fans, 92mm fans is enough. Maybe same 1800. And since the startup voltage on that power supply was 10 volt, maybe I could use even 2000 RPM fan. But I didn't have any more. Only that single 92mm fan. But here, on this power supply that I haven't tested, well, there is 92mm Noctua. Somebody has obviously modified this, because I don't think Noctua originally came in this power supply. So I'll take a look how fast that is, if it can be used, and use it instead. And it's also nice to take a look inside the quality power supply. But before I open this, this is 12 volt heavy. 2 rails of plus 12 volt, 70 amps and 10 amps, but only 20 amps on plus 5 volt and 15 amps on plus 3.3 volt. Look like it's 1600 RPM Noctua, but we'll take a closer look when I get this. And definitely someone's been inside. Not a nice way, but somebody has replaced the fan, obviously. This is really heavy, as I already mentioned. And those heatsinks are very thick. Maybe I can measure a little bit. 4 millimeters it seems. And this is 2005, week 24. I'm not even close to doing any benchmarks yet. But I did run that mem test and hard drive test, and this is indeed 92 millimeters, yes. I'm going to clean this. Here I have 2 ECC memory sticks, and why they are here? Well, let's go that to the moment. Because I tried to install Windows with 1 GB of memory that I installed here, and I didn't get far. Actually, it hanged right after you make all the selections about what you want to install, and when it actually starts to copy, then it froze just there. So it was expected that because I have 1 GB of memory, there will be issues, because Windows 98 weren't supposed to work with over 512 megabytes of memory. But it was actually quite easy fix, because somebody had already done the hard work. I found an image on archive.org, and it was modified Windows 98 CD, bootable CD, to make things even more easier, and it had the memory patches. Actually, you get to make selections. Do you want the patched version installed or not? And yeah, no problems with that. Windows installed quite fine, and no hangs after that. I haven't used this much, so just installed some drivers. The only issue was that I simply needed fixed Windows. But then I did some reading, and it's recommended by Intel that you use, and Asus as well, of course, because it's chipset related, that when you have 4 memory sticks, you should use buffered DIMMs. And what are the buffered or registered DIMMs? I have this ECC memory sticks here as an example. These all 3 chips are for buffering. That one is the same serial presence detect EEPROM that is also available on normal DIMMs. And that is clock chip. It takes only 1 clock from the DIMM slot, and it multiplies it for every chips on this DIMM. And these are for buffering, so it simply buffers address and whatever and presents them to the memory chips. And buffering, it's basically, it amplifies. The chipset itself doesn't have to run all these memory chips, so it reduces load to the memory controller. That memory controller that is basically these ECC memories. Well, they are always buffered sticks, but you can have buffered DIMMs even without ECC. Most likely you used buffered sticks without ECC when you have real many, twice the chips. So basically probably that means some early high capacity DIMMs might have been buffered but not ECC. And this chipset is of course ECC capable. And ECC, well, the chipset encodes additional bit to the memory, and then it decodes when it reads. And this encoding and decoding is much better than simple parity check, because you use some algorithm that is very easy to decode, so that even if one bit flips over, you can actually decode it back to the original value, and that's the ECC correction. And so now about the buffering. Well, when you use all 4 memory sticks, you should use buffered sticks according to Intel and Asus, of course. And probably that's the reason most of these BX-based motherboards only have 3 DIMMs. So you wouldn't run into some problems when you use 4 sticks. And of course 4 sticks is very much possible, because if you upgrade your memory, well, you probably use whatever you have, old DIMMs and new DIMMs and smaller capacity and high capacity DIMMs. And so you could have, for example, couple of 64 megabytes, then you add couple of 128 megabytes, or perhaps couple of 64 megabytes to get to total of 256 megabytes. But then you have all 4 DIMMs in use, and you should use buffered sticks, and none of those most likely aren't buffered. And if you use buffered, well, they all need to be buffered. So I didn't run into any problems. I ran the memtest that took over 3 hours to complete, and it was fine. And also the Windows installation was fine after I used the fixed image with all the RAM patches, unofficial ones that is. I don't want to take any chances, so I'd like to use buffered memory, but these are all I have. These 2 ECC, 256 megabyte, and also the buffering supposed to add 1 extra cycle, so it slows down. And I don't know if the ECC encoding also does reduce speed. I've never used ECC memory before, so it would be nice to experiment. And so it would actually, if you think about that, we want this to get this as slow as possible, and of course as fast as well. But since to go slow, you need to disable L2 and L1 cache. So that's where the memory speed matters most. And if you use slow memory, well, of course, the system gets even slower quite easily, actually. So maybe buffered sticks with ECC enabled would be real nice to get this to as slow as possible. That's something I'd like to benchmark. So we are at least going to use 2 of these. I'd still like to get the 1 gigabyte of memory, but I have only 2 of these. But then I have 3 of these 512 megabyte sticks. And well, they are not supposed to work, but with luck, maybe they identify as 256 megabytes and I can use them. let's take a look about this. Let's compare these Kingstons, for example. It looks like they use the very same PCB. Let's take a look from the back. Quick look also reveals that these two are unpopulated here as well, but really PCBs look identical. And now that we are here, we might actually take a look what I have installed here. These are Infineon, these first two, and these are not. So you have 8 chips on both sides, and you need to use double-sided DIMMs with 8 chips on both sides on this chipset. Because if you have 256 megabyte DIMM with only 4 chips on both sides, well, they are pretty much the same chips than on 512 megabyte modules, and they don't work on this old chipset. And these are the maximum capacity DIMMs that actually work here. And as you can see, we only have the identification EEPROM and memory chips and just some capacitors and some resistors as well. But no buffering chips of any kinds. And this is actually CL2 rated 123 MHz. And in fact, this identifies just as this 222 and 8 latencies. This is also Infineon, but 7.5 nanoseconds. But actually I tested it, and I ran the memory benchmark with CL2, and other settings were 3, 3 and 10, and it worked just fine. This also has the same Infineon chips, 7.5 nanoseconds, and also what I said about this holds true here as well. 2, 3, 3, 10 seems to work, and I haven't even tried anything faster. And this green memory it says on the memory chips. I already knew from previous experiments that this most likely identify as CL2, and this identifies as 2, 3, 3, 10 latencies. And yes, I ran the memory package with using all of these 4, and indeed it works, even though none of these are buffered or anything. And let's try this 256 megabyte ECC sticks here. But yeah, so I guess we're good to try this. And also I absolutely do not like this screwless, because when I plug monitor here, well, this moves too much, and I'd like to use at least one screw, but it's very hard to screw this with this on top of them. Actually, I think we should capture. We'll go with the BIOS settings as well and take a look on those as well. Let's see how it goes. Actually, I forgot postcard, but yeah, looks very good. But actually registered as SDRAM it says non-ECC, but I wasn't fast enough to get into the BIOS. So ECC most likely needs to be enabled. And now what? Looks like it froze here. And I don't have reset button, and the control del didn't work. Now let's try to get to the BIOS. Yes, now we're here. Why it only sees half the memory. Guess we'll need to try one at a time, if the other one is bad or not. And I have usual defined speed ratings, and perhaps these were the problems. Now I of course need to use these. These are not fast enough. Let's use defaults for now. I'm trying to see if there's ECC somewhere. There's only for the L2, but perhaps this needs to be enabled, so it actually enables also the... I don't know. We'll see it quite soon. We'll take a look about the BIOS settings later. Now, do we have... Still 256 megabytes. One unknown ECC. So guess we'll test one stick at a time. So let's remove this one. And try again. 228 megabytes. But I'm quite surprised this only detected at 228 megabytes. Let's try the other. Yeah, yes, 128 megabytes. Oh, here's the ECC. At least I found the ECC setting. Yes, now it's ECC. Let's shoot down and try the 512 megabyte. Let's try this one and see what happens. 128 megabytes. Why 128 and not 256? My guess is these DIMMs are too new. They basically use memory types that are not supported. 2000 week 39, 2001, and this 512, they are of course even later. Is this even 2005? 2000, yes it is. But here you can see the Noctua one. It is actually 1600 RPM as it should. It's connected to the motherboard. So I can get full 12 volts for it. And it pushes I think much better than the 1000 RPM fan. And it's still very silent, so I think this is very optimal for here. Optimal here. Very nice indeed. Alright, let's take the other. Let's try this compact one. Now we have memory error beeps. So yeah, that didn't work at all. Now let's add the 256 megabyte compact here. But at least I have something to test. I really want to test how much slower the C3 goes if I have these ECC registered memories here. But before going onward, here's something. And I started to first try to install the Windows. Well, I plugged this card in and set IDE to disabled. Let's see what happens. This is a problem I haven't encountered before. Floppy disk fail. In fact, it can find floppy disk drive here with this card jumpered like this and installed. And first I thought maybe this drive went bad or something. I tried another drive that worked before and same thing. So it's not the disk drive. It is this sound card, because when I removed it, everything worked again. So there's something wrong with the IDE disable on this card. Let's get it out of here. And I think this IDE tertiary IDE 1E8 is the default for this card. So I need to remove the IDE 100, and that's the middle one. And then we should be good to go. Because this sound card of course needs to be compatible with this system, because I used this back in the day. So is there some fault with this one, or let's move this to the other ISA slot, but I can't because there's those. Well, yeah, I think I can get it there. Yeah, no change, and there shouldn't of course be any change. Nothing. It's the same. So this card needs to be tested on another system. That would of course be my test bench, and we'll forget this now, and I'll try. I'll find something else with OPL3. But before doing that, I want to test that memory. Those 4 ECC sticks. So I'm going to run memtest now. It's going to take, well, perhaps less than 2 hours. So one pass is completed, and it took less than 40 minutes. And that's like much faster than with 1 GB. So you have to wonder, does this C3 Nehemiah actually cache all up to the 1 GB, or is it up to 512 MB? I couldn't find any information, so that's something that needs to be tested while doing the Windows benchmarks, game benchmarks and everything. I need to test with 512 MB of memory, because this is a lot faster than with 1 GB, and we are now using the slow ECC memory. Alright, let's take a look how this is doing, and it's been a few days, and this is quite hard, but it's not really any concrete or something like that, not that kind of hard, but I think that won't be a problem. Problem might be, however, how it stays on the socket. And but first, let's try to get it free. Too bad I didn't have any proper protective tape, so. But it seems to move. Yes, very good, very good. So I guess I need to push just there as much. Yes, now it's free. I should be able to get it off. Like that. And let's peel this one also. It may not be perfect, and of course it doesn't have to be, but it would be good if it won't come off right after I place cooler there. Let's try how this goes there. Quite nicely actually. Not bad at all. So only one thing remains. Can I actually mount a cooler here? I wonder how much you can overclock this. Maybe I'll take the 1200. No, let's take this. That has always been more problematic with multiplier of 11. Maybe this is better for overclocking. This is what I'm going to use. I have almost the same kind on the other slotket. This has center, copper center. I think this is a bit bigger. and this of course produces more heat than the C3. So that's why MX4 from Arctic. Let's see it this way. So this pushes to the center. And I suppose I'm going to place this gently. Yeah, it wasn't too tight actually. I wonder if it's too loose now, but no matter. Maybe I hit it one time too much, because I hit couple of times off camera and then one time when you saw that. Let's see. I suppose you can do it. Yeah, there's no problem. You can do it like this. And just for comparison, the other end. Here is the Nehemiah at the moment. And as you can see, the one on the Celeron is bigger. Both are for 80mm fans. And since the blades are not too close together, these are actually quite good for this kind of cooling when you have that one big fan and not right next to him, but there's a gap, few centimeters gap, so air pressure won't be very high, but it moves air from surrounding as well. And if you're wondering what's here, I'm at the moment testing the my Pentium 3, and this didn't cool it because, well, the heatsink is pretty much covered with that package there. So I had to remove this one temporarily, and so I could plug the fan that belongs to the Pentium 3. It got very hot with just this one, but yeah, these are both ready. I'm sorry if this video is about jumping back and forth different things, but I guess it can't be avoided. Well, let's take a look. That clip, by the way, it's still there where it's supposed to be. And based on my memory testing yesterday, this heatsink is very good here. It gets a bit warmer than with Nehemiah, and that's completely expected. And but it's only very little warm to the touch. Not even hot, not even close to being hot. So at least with case open, it is more than enough, this heatsink, plus this fan of course. I've now tested memory with my Pentium 3 as well as with this Dualatin Celeron, and there's absolutely no problem. Speed doesn't change depending how much memory you have, and not only that, all of my 256 megabytes DIMMs I've showed, well, they all can do CL2 and other timings 228, so they are actually very fast memories. But I can't overclock this to 133 bus, and I have set it to 224, or was it 25? I run memtest and that works very well. But thing is, I think this needs more voltage to boost at 133 MHz FSP, and since the BIOS sets it at the very end just before it starts to search hard disks, so I need to set the voltage ID to jumper, and hopefully that will get it to boost at 133 MHz. But let's test that right away actually. There's more to come, but let's set this one. Let me also explain a couple of things I want to try. This is last of my ECC DIMMs. It's 128 MB, but also this is from 2000 week 29. But the PCB is again exactly the same as on some of those 256 MB and 512 MB ECC DIMMs. So I really don't know what to expect. How does this detect as 128 MB? Or maybe half, who knows, but we're going to test this one. And just for being curious, here's 512 MB normal DIMM I want to test. Does it display as half, or does it not work at all? Because this has the Infineon memory and 7 nanoseconds, and so this should be fast, but just for being curious, I want to know. And also the Nehemiah. Indeed, I won't post at Vogons that someone else had noticed that with 768 MB of RAM, well, the Nehemiah gets very slow. And I've tested now with 1 GB and 768 MB, and indeed. But with 512 MB, it performs like it should. I've only run memtest so far, not real world benchmarks, but apparently 640 MB should also work fast, and after that would be, well, I had to say the real limit. But and of course, when I'm doing these slow down benchmarks, I really need to try with a lot of memory, because perhaps that feature or bug, who knows what it is, could be used as an advantage if you think you want to use the slot one system, so you can easily change CPUs between slow and fast. So just keep enough memory, and the Nehemiah will be slower than ever before, while whatever Pentium 3 or 12 in Celeron or whatever, it won't affect it, and you have lots of memory and it will be very fast. Although I'm hoping I can just keep the Nehemiah here and forget everything else, but that needs to be benchmarked. And there is an option, of course, intentionally use so much memory that Nehemiah gets very slow. And of course we need to test with Extra T. Is it the same thing? But now let's see what happens. It should just post because I have 125 MHz frontside bus set. But now I have the voltage ID to jumper set. Yes. 1364 MHz. Oh, I don't have keyboard, of course not, because it's on the other system. Another try. I don't know what happened. Perhaps this CPU doesn't overclock very well. But now let's set it to 1.55 volts. I have these timings because it looks like these memories can do it, at least 3 at a time. I haven't actually tested it all 4. Let's just see what happens. Yes, now it posts with voltage ID 2 jumper set. It didn't have enough voltage to put. I'm not going to run the memory test at the moment, but of course I'm going to run the benchmark of camera. But yeah, we are now at 1463 MHz or something, or 66 maybe it should be. But yeah, so that voltage ID 2 jumper, well, you can use it on overclocking situations. So perhaps if you do these mods on your slotket, you might actually want to keep that voltage ID 2 jumper there. I'm setting this to something else. Let's forget about overclocking for now. Let's do something completely different very soon. But now let's test this 128 megabyte ECC. Yes, it posts 128 megabytes. So this indeed does work as it should. Both are even compact modules. Same PCB. Well, no, that's this. Well, it is, but this might actually help. On the back side, Hyundai both have Hyundai's memory chips, and if this detects that 128 megabyte as well, well, that's too bad. So let's quickly test this 512 megabyte. It posts at least 256 megabytes, so it shows us half. So now I'll show you something. Because of the issues with the other sound card that I'm going to try later on the test bench, well, I'm going to use this instead. This is CT3600. It modified to use real Yamaha OPL, and this later low power version, well, it's just as speed sensitive as the older OPL3. So I can use this here to test the OPL3 to find suitable speed settings. So all the most sensitive OPL games work. But let's not put this here yet. Let's fix this Audigy too, and I think this is the last thing I'm going to do on this video. We'll take a look at this soon, but I'm going to install drivers of camera, and then we'll take a look how this sounds. So you heard it, and it can sound even worse. More crackling, perhaps popping, but yeah, it doesn't sound healthy. And apparently these were 22 microfarad capacitors need replacement, and you should replace them with 47 microfarad capacitors. And why? Let's take a look Audigy 1, because you also have on the very same corner VRMs, but here on Audigy 1 they used 47 microfarad capacitors. Both are Jamicon branded, but there appears to be one more here on Audigy 2, but 2 VRMs on both of these cards. So apparently 22 microfarad isn't enough, so I wonder why they went from working design to design that, well, doesn't work. So let's replace them, and only them, and see if it helps. Actually, I'm going to replace them off camera. Alright, capacitors are now replaced. 47 microfarad, 16 volt. But before we try the card, let's actually check how this measure. ESR is 7.3 ohms, and that's quite a lot. But they are almost 24 microfarad. Let's test another. Yeah, it's 43 microfarad and 150 ohm. The microfarad reading, I think I read somewhere for Vogons most likely, that if the electrolyte starts to react with the aluminium, it can actually raise the capacitance, but that is just the first sign of cap going to fail. And this is 22 microfarad, so definitely this is a bad capacitor. Now how about this one? This is same as the first one, 7.6 ohms about, and microfarad reading is what it should be, but at ear size is higher than it should be. Yeah, this is the same as the second one. Now it says almost 85 microfarad, but and 150 ohms ESR. This is a bad caps for sure. Yeah, these are bad. So let's try the card. Alright, just some final words before ending this video. Now this is the Audigy 2 that we replaced those capacitors. And the other Audigy 2, same model, is on the system right now, and it works perfectly. Absolutely nothing wrong with it. It will need eventually, those same capacitors need to be replaced, and but it's not at that position at the moment, so it still works. And really only difference between this card is 3 of those capacitors seem to be WinCap branded and only 1 Jamicon. I don't know if it makes difference, most likely not. Perhaps this is simply less used card, who knows. But it works. And I've been thinking, how should I do all these testings? Oh, and one more thing about these Audigy cards and Sound Blaster Lives as well, because Sound Blaster Live, well, if you want to limit your system to DirectX 7, well, the Sound Blaster Live is the safe choice because it has such old drivers. But Audigy 1, it was released when DirectX 8 was already released, and I think worst driver CD came with DirectX 8. And DirectX 9, well, perhaps that's a bit new for Windows 98 systems. And Audigy 2 came with that one. The driver installation installs it. But I've installed drivers using the guide on Vogons by Joseph Joestar. I'll put link in the description, where you manually install only what you need, so no bloat or anything. And I skipped the DirectX 9 installation. I have 7 at the moment, but so far 3D Mark 2000 demo, Unreal Gold, Quake 2, those I've tried, and audio works in all of them. So I suppose you don't necessarily need DirectX 9 or even 8. I really don't know how I should start testing this, because I don't want to reinstall same drivers over and over again, so I should change CPU rather than card and test single card with all CPUs. And there's now a bit of a problem with that one. Here's the fixed slotket again. I tried to remove the heatsink from this fixed side, when I should have tried to get it out from here, the other side. And this is what happened. The middle one broke and the newly made as well. I'm going to redo this. That one I've already glued just a while ago. And I'm going to do the same thing all over again. But this time I don't know how well it shows, but there's two holes that I made that I hope the new tab there will hold a little bit better, but same process, and I've already covered this with tape, so I'm going to make one last time, and after that, whatever CPUs I install there, it's going to stay there. Changing the heatsink is too much of a stress for this fixed socket. This 1100 MHz dual in Celeron. Well, I got it to 133 MHz frontside bus, but it required 1.6 volts to pass a memtest. 1.55, well, it just froze after 9 minutes or so. And since that doesn't even stress FPU, it's very much possible that this CPU isn't even stable with 1.6 volts. It's going to need even a bit more, and that's already too much I'd like to use. And with this other Celeron 1200, well, it might be better, who knows. But there's the higher multiplier. Well, of course, if I'm going to set FSP to 133 MHz, well, this is going to be faster than what Intel even released this dual-in cores, so it will almost certainly need as much voltage as this one. But if I could get it somewhere less, 1500, well, perhaps this would work with less voltage, but who knows. This wasn't ideal, but still, if you want to use graphics card such as this, that doesn't work with 89 MHz HEP, and ATI drivers are supposed to be matured really well for Windows 98, so this should have very good drivers. Just get the last one, unlike on Nvidia, where you have to pick your cards and driver versions if you want older games. But this should be actually even better. But you can't use 89 MHz HEP, so this Celeron with higher multiplier, well, perhaps just use 125 MHz frontside bus or 115, and you get still fast CPU but slower HEP, and perhaps this would work. I'm going to try this sometimes, and suppose that's all. I'm going to install the ISA Sound Blaster 32 CT3600 also here, and I think then, and I'm going to use my old card that we fixed instead of this one. But I could suppose then I can start doing the benchmarks. There will be a lot of them, and I hope you watch the next part as well. And I'm also going to need to test the Nehemiah memory issue. Does it show on those benchmarks? Because that could be something to make the CPU even slower. But those will be in part 3. Thank you for watching, and see you on the next video.